Greetings, students. Welcome to Mr. Wong's Distant Learning Week 6 for Monday's lesson, May 4th, on multiplying and dividing integers. Homework can be found in the eCampus link. Go ahead and click to download and complete, as this is not in your workbook. Let's proceed with the lesson. Multiplying and dividing integers. Take a look at the key ideas. Take some time to write these in your notes to be able to use for your homework. Multiplying integers with the same sign. The product of two integers with the same sign is positive. 2 times 3 is 6, and negative 2 times negative 3 is also positive 6. Multiplying integers with different signs. The product of two integers with different signs is negative. 2 times negative 3 is negative 6, as well as negative 2 times 3, also negative 6. Let's take a look at an example. Find negative 5 times negative 6. Since the integers have the same sign, the product is positive. It's positive 30. What you can do is always multiply the factors of 5 and 6 to get 30, then determine whether the product will be positive or negative based on the rules we saw on the previous slide. Let's continue. 3 times negative 4. Remember, multiplying is also shown as a number on the outside parentheses. So in this case, 3 times 4 is 12. Let's follow the rules. Are the signs the same or different? Since they're different, the answer will be a negative 12. How about negative 7 times 4? Again, let's first approach the problem by multiplying 7 times 4, and we get 28. Now we have to determine if it's negative or positive. Since the signs are different, we use the rule and apply, and the answer is negative 28. Again, when the factors have different signs, the product is negative. Now it's your turn. Go ahead and copy these questions and then answer them in your notebook or a sheet of paper. Let's look at the tips on the bottom of this page. I want you to count the number of negative factors in the problem. If there is an even amount, the product will always be positive. If there's an odd amount of negative factors, the product will be negative. Remember, the tip is to multiply the values first, then determine if the product is negative or positive. Go ahead and pause the video now, copy the questions and respond, then resume the video once you've completed the task. Welcome back. Let's check your solutions. Number 1, 5 times 5. We know this one's 25 without even having to apply the rule that the signs are the same. It just looks like a regular problem we worked with before. The same goes with number 2, 4 times 11. That's 44. Question 3, 1 times 9 is 9, and again the signs are the same, so we know that it's positive 9. Number 4, negative 7 times negative 8. We know the product is 56, but let's determine if it's negative or positive. Again, applying the rules that the signs are the same, so it's going to be positive 56. Number 5, 12 times 2. That's 24, and since the signs are different, the answer is negative 24. 4 times 6, also 24, and the same rule applies because the factors have different signs. The answer is negative 24. Now here comes the troubling part. We now have 3 factors being multiplied. Let's apply the rule that if there's an even or odd amount, it'll determine whether the product is negative or positive. Negative 10 times negative 6 times 0. We count that there are 2 negative factors, and 2 is an amount that's even. The product will be positive. However, in this case, when I multiply by 0, anything times 0 is 0. And remember, 0 is neither negative nor positive. Let's go to the next one. 7 times 5, that's 35. And 35 times 4 is 140. Now let's apply the rule again. How many negative factors do you see? I count 1, 2, and 3. 3 is an odd amount, and that means the product will be negative. So we get the result of 140 but it's going to be negative 140. Take a look and review your responses to see if they match and make changes when necessary. Again, we can actually write a rule about problems with more than two factors and negative numbers. What if there were 12 numbers being multiplied together, but 5 of them were negative? Would the product be negative or positive based on this rule? Again, 5 is an odd amount, so the product will be negative. Any even amount of factors that are negative, the product will always be positive. Let's continue. Now let's go over the rules for multiplying integers, but as exponents. It wants us to evaluate negative 2 to the power of 2. With the negative 2 in parentheses, this exponent of 2 means that the factor occurs twice. Negative 2 to the power of 2 is equivalent to negative 2 times negative 2. Whenever we see an exponent, we always want to write it as repeated multiplication. Now we multiply. 2 times 2 is 4, and since there are 2 negative integers, 2 being an even amount, the result will be positive 4. Now take a look at part B. It's asking us to evaluate negative 5 to the power of 2. Remember, in part A, the negative 2 is in parentheses, so the entire expression is raised to the power of 2. In this case, there is no parentheses, so it's actually asking us what is the opposite of 5 to the power of 2. In this case, only the 5 is being multiplied by itself, with the negative, without parentheses, being on the outside of the repeated multiplication. 5 times 5 is 25, with one negative sign, so the answer is negative 25. It is important to look for these parentheses around expressions before you see the exponent. Remember, when the expression is in parentheses, the exponent applies to the negative sign as well as the value. When there are no parentheses, the exponent only applies to the value and save the negative sign for the end. Let's apply this rule to solve these next questions on your own. Remember the rule to solve these problems. Again, go ahead and take some time to copy these questions on your sheet of paper or notebook, then try to answer these, and then resume the video to check your solutions. Pause the video now to work on this. Welcome back. Question number 9 asks us to evaluate negative 3 to the power of 2. Again, since the negative 3 is in parentheses, the exponent 2 applies to the negative 3 altogether. That means there will be negative 3 times negative 3. Since there are two negatives, we know that the answer will be positive. And 3 times 3 is 9, resulting in positive 9. Question 10 says negative 2 to the power of 3. Again, the negative is inside parentheses, so the 3 applies to the entire expression. So negative 2 times negative 2 times negative 2. There are 3 negatives in this expression. And since that is an odd amount, the product will be negative. So now that we know the sign to use, it'll be a negative answer. We just have to find out what 2 times 2 times 2 is. 2 times 2 is 4, times 2 is 8. So the result is negative 8. Question 11. Negative 7 to the power of 2. There are no parentheses in this case enclosing the negative and the 7, so the exponent only applies to the 7. 7 to the power of 2 is 7 times 7, which is 49. With the single negative in front, the answer is negative 49. And finally, negative 6 to the power of 3. Again, since there are no parentheses around the entire expression, the exponent of 3 only applies to the 6, then making the answer negative. 6 times 6 is 36, and 36 times the third 6 is 216. Again, since there's only one negative, the answer will be negative 216. Did your solutions match the ones on screen? Great. Now let's take a look at the rules for dividing integers. Dividing integers with the same sign, and dividing integers with different signs. Go ahead and take these notes and put them in your notebook to be able to use for the homework later. The quotient, which is the answer to a division problem, of two integers with the same sign is positive. We know that 8 divided by 2 is 4, and again, since the signs are the same, it results in positive 4. Negative 8 divided by negative 2 is also equal to positive 4, again based on the rule that the two integers have the same sign. How about dividing integers with different signs? The quotient of two integers with different signs is negative. Again, 8 divided by 2 is 4, but since the signs are different, the answer is negative 4. And the same applies to negative 8 divided by 2. That also equals negative 4. Do these rules look familiar? That's right. They're the same rules of multiplication. So let's apply the same rules and divide integers with the same sign. Negative 18 divided by negative 6. First, look at the factors 18 and 6. 18 divided by 6 is 3, and since there are the same signs, we know that the answer will be positive 3. Same rules as before. Every two negatives make a positive when multiplying or dividing. In this case, there are an even amount of negatives, so again, the answer is positive. What about dividing integers with different signs? 75 divided by negative 25. Let's first apply the values and do 75 divided by 25. We get 3. And since the signs are different, or an odd amount, we know that the answer is negative 3. Let's look at negative 54 divided by 6. Remember, numbers placed as a fraction also mean division. Before we determine the sign of the quotient, let's first figure out what 54 divided by 6 is. We know that'll equal to 9. And since there's opposite signs, or one negative sign, we know the answer will be negative 9. Again, with two numbers being multiplied or divided together, when the integers have different signs, the quotient is negative. Now go ahead and try these on your own. Go ahead and copy these 6 questions in your notebook, and then work these out by applying the rules to dividing with integers. Then resume the video to check your solutions. Pause the video now to complete the task. Welcome back. Let's check our answers. Again, by applying the same rules that we use for multiplying, also to division. If there is an odd amount of negatives in the problem, the solution will be negative. If there's an even amount of negative symbols, including 0 negatives, the answer will always be positive. So again, the first thing we should always attempt is to solve with the values given before we determine the sign. 14 divided by 2 is 7, and since there are no negative signs, the answer will just be positive 7. Number 2, negative 32 divided by negative 4. Again, let's determine 32 divided by 4 first before we determine the sign. 32 divided by 4 is 8, and since there are two negative signs, the answer is positive 8. How about negative 40 divided by negative 8? Again, 40 divided by 8 is 5. With two negatives being an even amount, it will result in a positive answer, so positive 5. 0 divided by negative 6. Well, since there's one negative, the rule says it's going to be a negative answer. But let's put this into context. What if I had 0 candy in my treasure box and I want to share it with 6 students? How much candy will each student get? The result will be 0. And 0 is neither negative nor positive. Question 5. Negative 49 divided by 7. Again, remember, numbers placed as a fraction also mean division. 49 divided by 7 is 7. With one negative sign being an odd amount, the answer will be 7. And finally, 21 divided by negative 3. 21 divided by 3 is 7. With one negative sign, the result is negative 7. What if we were given variables instead of values to reuse the substitute? Let's have a look. It wants us to evaluate these expressions when a equals negative 18 and b equals negative 6. In the first term, a divided by b, it'll be negative 18 divided by negative 6. We know 18 divided by 6 is 3, and since there are two negatives, the result is a positive 3. What about number 8? A plus 6 divided by 3. So we substitute a negative 18 here. What's negative 18 plus 6? we'll have to apply the rules of adding integers. Since the signs are opposite when we add, we have to subtract them and then use the sign of the larger number. So 18 minus 6 is 12. Use the sign, it'll be negative 12, then divided by 3. 12 divided by 3 is 4, and since it's negative, the result will be negative 4. And finally, b is negative 6 to the power of 2 divided by a plus 4. We substitute negative 6 for b and also negative 18 for a. Since we see the exponent of 2 applied to b, that means the entire negative 6 is also being applied to the exponent. We have to make sure we use parentheses in this case. After substituting, we'll get the expression negative 6 to the power of 2 divided by negative 18 plus 4. Negative 6 to the power of 2, since there are two negatives, will be positive 36. We still write the rest of the problem, negative 18 and plus 4. 36 divided by 18 is 2, with one negative sign, so it's negative 2. Again, rewriting the plus 4 that we didn't use yet. Finally, our final expression is negative 2 plus 4. We have to apply the rules that we learned for adding integers. Since the signs are different, we have to subtract them and use the sign of the larger number. 4 minus 2 is 2, and since the larger number is positive, the answer is positive 2. This sums up the lesson on multiplying and dividing integers. Homework is available on eCampus. The multiplying and dividing integers, the homework has questions 7, 26, 28, 34, 40, 24, 28, 30, and 31 to give yourself ample practice on multiplying and dividing with integers. Click on the homework link for May 4th, 2020 to download and complete. You can work on a sheet of paper. Always copy the problem before solving. You may also print and work out the problems. Go ahead and take a photo of your work and submit your emails to me to receive credit. Until next time.